You'll always measure at a right angle, never measure at a not right angle. Okay, it's just by convention. It's called, the distance is called the perpendicular distance. Distance to the line.
What is it there? Perpendicular? What does that say? I have no idea.
Perpendicular distance to the line. The distance is always the perpendicular, the distance measured at a right angle. We'll never measure at an angle that's not a right angle, if I measure distance. You'll never put your ruler on this point and measure the length from the point of the line at anything other than a 90 degree. Always at 90 degrees. Never measure, we'll always measure at a right angle. We've got two theorems here that may seem commonsensical, but you could show they're true. In fact, I believe we actually had an exercise on one of the homework assignments. I believe it was on the worksheet we did back in chapter 2. That we actually showed that this is true. We showed that if two lines intersect to form a linear pair of congruent angles. So if you have two lines that intersect, you get a linear pair, so a straight line, and the angles are congruent. If this is true, then what do you know about these two lines? Well, what did we show last chapter in that worksheet? What did we show we know about the measures of those two angles? These angles are forced to be 90 degrees. And if they're forced to be 90 degrees, then what do you know about the relationship between those two lines? What do you call them? Line G and line H. Perpendicular. Then the lines are perpendicular. So if this is true, then G is perpendicular to H. The symbol for perpendicular being the upside down T, perpendicular line. If two lines are perpendicular, then they intersect to form four right angles. Or if we have, well, we know that A is perpendicular to B, then 1, 2, 3, and 4 are all right angles. Or they equal, or their measures, excuse me, or their measures add up to 90 degrees. And I'm going to tell you that angle 1 and angle 2 are congruent. From like the new, what are some new things we could conclude based on like these theorems or these ideas that we just talked about? What are some new things you could conclude about the diagram? If we start with angle 1 is congruent to angle 2, Joel, what's one thing you could conclude?
Or line 1 and line A and line B are perpendicular.
Line A and line B are perpendicular. That's definitely something you could conclude. That's from this first theorem. If they intersect and form congruent linear pair, then they have to be parallel. Or, sorry, perpendicular. Measure angle 1 plus equals measure angle 2, which is 90 degrees. Something else you could definitely conclude. And what is something else we definitely know? Maggie? No? Kate?
That angle 3 and angle 4 also equal 90.
Okay, if you label in 3 and 4, you could say that we know that there are 4 right angles. You also know that there have to be 4 right angles. I just want to tell it to you. If two sides of two adjacent acute angles, holy cow, let's stop. Two sides of two adjacent acute angles. So in this, I'll draw a little picture here. Adjacent means sharing a side. Acute means less than 90. So I have two angles that are less than 90 and they share a side. I'll say angle 1 and angle 2. I have this diagram so far. And also, what do I know about those two? What if I, in addition, know that they're perpendicular, that those two sides are perpendicular? So this theorem says that if I start with this picture, two sides of two adjacent acute angles, two sides of two adjacent, smaller than 90-degree angles, if they're perpendicular, if that's true, then I know that those angles have to have a special relationship. What relationship is that? Then they must be complementary. If you start with this picture, then you know that measure angle 1 plus measure angle 2 must be 90 degrees. Let's use some geometry to help us create an algebra equation and then solve this equation. So let's take some ideas. What are some things we've learned at this part, these theorems? What could help us set up making a relationship in this picture? We know that those are perpendicular, right? So then what else do we know, Paige?
That the measure must be both.
Then if these are perpendicular, then we know that there are 4 right angles. In particular, we know that that's got to be a right angle. And if this is a right angle, then this theorem, two adjacent acute angles that are perpendicular, what do you know about their angle measures? Complementary. So Joel, what equation can we write then?
51 plus 2x minus 11 equals 90.
Then you'd be allowed to write this equation. From here, now that you've left the geometry realm and entered the algebra realm, now you could solve this equation to figure out what x needs to be. So you could say what? 2x plus 40 is 90. 2x equals 50. X therefore is 25. The perpendicular transversal theorem, it says that if you start with this picture, if you start with two parallel lines and a transversal that's perpendicular to one of them. If you start with two parallel lines and a transversal that's perpendicular to one of them, what is something new we could conclude? What must be true? Dimitri?
The bottom one must be perpendicular to both.
Then that guy better be a right angle as well. That you know this picture implies this picture. This picture means this picture must be true. Means that it must be perpendicular to K. That it's perpendicular to the other. Why would that be true? What would be how would we explain that has to be true?
Blanking on the name, not consecutive, the other C1.
Corresponding?
Corresponding, thank you. Corresponding interior angles.
So if you have if parallel lines, then F patterns are congruent. So if parallel lines, then corresponding angles must be congruent. And if that's 90, then that's 90. And if this is 90, then J and K must be perpendicular. So if H is parallel to K and J is perpendicular to H, then J is perpendicular to K. Okay. Conversely, if we start with the reverse picture, if you start with two lines that are perpendicular to the same line, then what do we know about the relationship between these two lines? These lines must be parallel. And why would they be parallel? What would be an explanation for why M and N must be parallel? Given that I know that P is perpendicular to both of them. what could you say? What would be a reason that we had, say, yesterday that would explain why M and N have to be parallel? What would be a reason? We had one of them yesterday. Kelsey? The corresponding angles converse would tell us that. Because if you have right angles, and if we know that and right angles are always the same measure, since these two angles are the same measure and they're corresponding, that forces M to be parallel to N because of the corresponding angles of converse. Then we know that M is parallel to N.